Hey guys, we are going to start chapter 8, which is going to be all on geometry or shapes. So this first lesson is going to be on some vocab with polygons and explaining what polygons are. I can't find any good practice problems on GMM for these, so I actually just attached a worksheet that I made in Forms, and I put the link to that in Planbook. So when you are finished watching this, go ahead and complete that worksheet. There's 15 problems on it. It should not take you long. If you watch this video, you can even kind of screenshot some of the slides or keep the video in another tab so you can go back and look at it, anything like that. I can actually even upload this PowerPoint as well. So if you need to go back and look at definitions, you can do that too. That might be helpful. So I will do that as well. All right, so with polygons, a polygon is a closed figure. So what it means by a closed figure, it means that there's no open spaces. It means all the lines connect, and it's made up of straight segments. Okay, so there's no curved lines. All right, so the way I use to explain this, there are no gaps. There's no gaps, overlaps, or curves. Okay, those are the three things you have to check. There's no gaps, there's no overlaps, and there's no curves. So for example, that's not a polygon because there's a gap there. That's not a polygon because there's an overlap. That's not a polygon because there's a curve and kind of a gap. Okay, has to be only straight lines, and they have to all connect, and there can't be any overlapping. So once you have a polygon, there's two ways you can identify them. Okay, there's concave and convex. So if you have a concave figure, like a star, pretend that those actually, connect, like a star, that means that is concave because you can draw a segment between 2 points. I can pick this point and this point in the polygon, and when I connect those, my line goes outside of the polygon. The easy way that I use to remember this is that the polygon caves in for concave. Do you see how these are really ugly stars I'm drawing with this? Do you see how it kind of caves in there? Or if you had one like this, okay, it caves in. All right, so that's kind of the easy way that I use to remember that. And then you have the other that is convex. Okay, so convex is just the opposite. So that says you have a polygon and you can draw a segment between any 2 points and it'll never go outside. Okay, so it doesn't cave in. There's no areas. So again, concave would be where it has a part of it that caves in. Convex, it doesn't cave in anywhere. Okay, those are just the easy ways that I use to remember those two words. So we're going to state whether each is a polygon or not a polygon. All right, remember the three things you need to know with a polygon is that there's no gaps, no overlaps, and no curves. Okay, so looking at number 7, there's no gaps, there's no overlaps, and there's no curves. So that is a polygon. On your 15 problem assignment, I think I have 4 or 5 of these. All you're going to do is, it's multiple choice. It says polygon, not a polygon. You're just going to click which one it is, so it shouldn't take long. Number 8, there are no gaps, there are no overlaps, and there are no curves. So that is a polygon. Number 10, there's no gaps, there's no overlaps, but it's one giant curve. So that is not a polygon. Okay, a circle is not a polygon. Number 11, we see there's a gap right there. So that is not a polygon. Okay. Example 2, state whether each polygon is convex or concave. Again, concave means it caves in. Looking at this one right here, that caves in, so it's going to be concave. I can pick 2 points and draw a line between them, and it goes outside of the polygon. Okay. Number 8, it doesn't cave in anywhere. You can pick any 2 points, and it's never ever going to leave the outside of the polygon. That is convex. Number 10, again, nowhere caves in. I can pick any 2 points, and they're never going to leave the outside. That is convex. Number 11, caves in. That is concave. I can pick 2 points and connect them, and it goes outside of the polygon. Okay, again, these are all polygons. We're just classifying whether they're convex polygons or concave polygons. All right, next we're going to learn how to name the polygons based on the amount of sides. Okay, so these numbers over here refer to how many sides you have. If you have a 3-sided polygon, that is called a triangle. A 4-sided polygon, so I'm not going to draw them because it'll get really hard down towards the bottom. So a 3-sided polygon is a triangle. A 4-sided polygon is a quadrilateral. A 5-sided polygon is a pentagon. 6-sided is a hexagon. 7 is a heptagon. 8 is an octagon. 9 is a nonagon. 10 is a decagon. 11, I use undecagon. There's actually another name, I think it's like hendecagon or something. There's 2 different, or maybe 3 different names people use for 11. I just go with undecagon. I feel like it's the most used. And then 12 is dodecagon. Okay, anything after 12 doesn't get a special name. We just refer to it as an n-gon, so like a 13-gon, 14-gon, 15-gon, 16-gon, etc. All right. Triangle, you should know. Quadrilateral, 4 wheels is a quad, so that one should be pretty easy. Pentagon, you think of the building. It's 5-sided, right? Pentagon. That's pretend that it lines up. Hexagon, you should know. Heptagon, maybe new for you. Octagon, you should know. Nonagon should be easy because it's almost like 9, but with an O. Decagon, you may know. So when we're doing undecagon and dodecagon, the way I think of Spanish, right? Uno, dos, so un, do. That kind of helps me keep it in line, whether it's undecagon is 11 because it refers to 1, and dodecagon is 12, refers to 2, uno and dos. So those are some helpful ways. But yeah, like I said, really the new ones for you may be, and you may already know them, would be heptagon, nonagon, and then maybe 10, 11, 12, but they're not too hard to, once you know 10, it's really easy to know 11 and 12. Okay? All right, so now we're going to name each polygon. So we're going to count the amount of sides. So these are all polygons. This is a convex polygon here. We're going to count 1, 2, 3, 4, 5 sides. So that is a pentagon. Okay, this again is a convex polygon. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides, so that's an octagon. Okay, so the difference between 1 and 2, this pentagon in number 1 is actually referred to as a regular polygon, and the reason for that is that all of the sides are the same. All of the sides are the same size. They're congruent. Okay, so we refer to that as regular. Number 2 is an irregular, meaning that the sides are different lengths. I'm not going to, put problems with regular and irregular on. I just want to let you know that those words, do exist. Number 3 is a concave polygon. What happened to my pen? There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So that is a nonagon. And then for number 4, this is another regular convex polygon. 1, 2, 3, 4. That's a quadrilateral. All right, now speaking of quadrilaterals, we know that this is a square. Okay, we're going to learn a few of the quadrilaterals and what their specific names are. So quadrilaterals refer to any four-sided polygon. Okay, and then we have like kind of a family tree here with quadrilaterals. So if you have a parallelogram, that is a quadrilateral with opposite sides being parallel. That means this side is parallel to this side, and this side is parallel to that side. Okay? Now, you can have a special parallelogram, which is a rectangle. It has to be a parallelogram with 4 right angles. So all of these angles must be right angles. All right, you can have another type of parallelogram, which is a rhombus. So it's a parallelogram with all sides equal. So this side is equal to this side, is equal to this side, is equal to this side. Now, what I always say, if a rectangle and a rhombus had a baby, it would be a square. Okay? It's a rectangle and it's a rhombus, which means it has 4 right angles, which comes from the rectangle, and it has all equal sides, which comes from the rhombus. Okay? And then on the other side of quadrilaterals, this is not a parallelogram, is a trapezoid. A trapezoid is a quadrilateral with only one pair of sides parallel. So here are your parallel sides. The other two are not parallel. Parallelograms must have 2 sets of parallel sides. A trapezoid only has 1. Okay, and we're going to name some quadrilaterals. We're going to use the most specific name. So this is a parallelogram because it has opposite sides parallel, and it also has right angles. So that would be a rectangle. Okay, I know that you would already know that one. It's an easy one. Same with this one. Okay, all congruent sides, all right angles. That is a square. Easy, easy. Right, down at the bottom might be the newer ones for you. This has 1 pair of parallel sides. Notice that these sides are not parallel, so only 1 pair of parallel sides is a trapezoid. And then this one has 2 sets of parallel sides, and they're all the same length, so that would be a rhombus. And then lastly, this one has 2 sets of parallel sides, and that's it. So it is a parallelogram. Okay, like I said, I'm going to upload this PowerPoint and also the video, so you can watch the video. And then if you want to open up the PowerPoint while you're doing the worksheet, then that might be helpful for you to look back at all of the vocab, because I gave you a lot of vocab just in one lesson. All right, on Monday we're going to move on and go back to GMM, but I wanted you to get this vocab so that whenever I talk about different things, you are a little bit familiar with it. Okay, good luck.